Hello everyone and welcome to a new discussion which we are going to have today on springs, which is a very important aspect in groundwater engineering. So, before we discuss springs, let us see an excellent example of location of riverbed well for drinking water supply, because this part I wanted to include in earlier discussions, but somehow it was missed. So, I thought that I will discuss before we discuss the springs. Here you see this is one of the very good example of riverbed drinking water well near Devprayag, and when you are coming towards the Rishikesh. See here in hilly terrains the difficulty is how to get water, and especially clear water, clean water from the river for the water supply. So, if you see here in this you can locate a riverbed drinking water supply well. I will zoom it this part, and this photograph was taken by myself, which impressed me about the location and other things also. If you see that a river is bending here due to the hard rocks present in the surroundings, and so when it was the site was being decided, it was decided inside the bend, so that the erosional activities will not take place, and this riverbed drinking water supply well will remain intact in future also. So, this kind of structures you might observe in many areas may not be all the time in a hilly terrain, but in a flat terrain also. So, this is I thought this is a very good example of to show how the river bed drinking water supply well can be located and used for water supply. One more slide is here that you can also observe. So, that the well is intact because the this inside of the bend is having deposition. So, there will not be any problem, and the sand is also available, which will serve as a filtering of for the groundwater, which is supplied to the Devprayag city. Now, let us come to our topic, which is today we have chosen the springs, and way back between 384 to 322 BC, Aristotle mentioned that most springs are in the neighborhood of mountains and high grounds, suspended like saturated sponge, make the water ooze out and trickle together in minute quantities, but in many places. Today, if you see any hilly terrain, for example, our Himalaya, every words which are mentioned here will fits there. That in the neighborhood of the mountains or within the mountains, high grounds suspended like saturated sponge, make the water ooze out and trickle together in minute quantities. So, it is not necessary that all springs will have very high flow. Some springs may have just trickling of water, and maybe 1 liter in 1 minute or 5 minutes even, but still they are useful for the local people to get the water. If I give an example here, this photograph which is taken in the Himalayan region, that spring is a natural exit point at which groundwater emerges out of aquifer. So, it is a modern way of defining a spring is that when, because of topographic arrangements, and when the groundwater surface is encountered with a sudden change in the slope, then springs are formed. So, here the springs, that groundwater emerges out of aquifer and flows into top of the earth's surface, as we are seeing here. So, a little differently, Aristotle and now springs are being defined like this. The spring is nothing but a manifestation of groundwater exposure on the surface. That is the most important thing here. Now, springs as you know have played a very important role in the settlement pattern of many lands, including our Himalayan terrain or other hilly parts of India as well, or globally also. And these springs have served as a local water supply. So, in mountainous terrain when you are having springs, that means you are having water, and if it is perennial spring, then definitely the settlement will take place there. So, as you can see here on this schematic diagram, that there is a recharge zone, because after all the water which is coming out of springs have to have a recharge zone. So, here in this example this is recharge zone, and this is coming through the porous layers and appearing, this spring is appearing here, and therefore, you are seeing vegetation, habitation and everything, and this is typically what is happening in Himalayan region. The local people who are living here may not be knowing which is the recharge area, but they are getting water, and sometimes the recharge area might be in, see this is topographic high or ridge. So, it is coming from other side or other watershed or basin, but still this groundwater is emerging out of a topographic surface and providing water for local water supply. Whereas springshed, there are two things which we will discuss in detail, but let me introduce here first. There are two terms, one is called watershed, another one is called springsheds. So, in springshed, identification of springsheds is challenging, but it is important to have springs in forever. If we are having known recharge areas and some treatments are done, then we will have water supply through springs for longer time. So, springs like watershed management, springshed management is also equally important, that we will see little later. Now, many springs are having mineralized water as well as thermal water. Sometimes the water is coming from deep from the earth and the water temperature is high, and such high temperature water which is coming off springs also carries lot of minerals, especially sulfur and other things. And sometimes people find that these springs are having medicinal value or therapeutic values, and they go and take bath in that, and many skin related diseases are cured in such waters. So, importance of spring is evident from many localities, and their names are also based on the springs, and settlements of course is there. So, as said that springs will have one recharge area and of course discharge area. So, the discharge that is fairly constant or discharge may vary. Now, many springs in Himalayan conditions or Himalayan terrain, if I give example, many are perennial, round the year you will have the water, and many are having ephemeral kind of season, that only in monsoon time and little later they will have water, but in rest of the season you will not have water. Further, many springs will have, like monsoon season may have very high discharge, but later on the discharge may reduce. So, it depends on the size of springshed which is supplying water to that. So, a springshed can be permanent or ephemeral or perennial, we can say perennial and ephemeral. So, this water which is coming out of a spring, it is having the value, and if you go in Europe, the bottled water which is mentioned is spring water, which is very costly to buy rather than processed water. So, spring water, because it carries lot of dissolved minerals of many different types or certain dissolved gases or petroleum also. So, sometimes you may find that water may not be even drinkable, and but it's not a very common thing that you will find certain dissolved gases or petroleum, but otherwise you get a lot of dissolved minerals which are good for health also sometimes. Now, we talk also about thermal springs, we will be talking further on that the temperature of water may be close to the mean annual air temperature or the lower or higher even boiling point. So, because it is a, after all it is a groundwater. So, the groundwater may have different temperature than the atmospheric temperature, and sometimes the water is coming deep from the earth, and therefore, it may have very high temperature even up to the boiling point. And I will also show you little later, maybe here in this discussion or in future discussion, that there are many sites in India where the water which comes out these springs is really boiling water. People cook rice and lentils and other things there. Now, as we have already discussed that the flow from these springs may vary from a barely perceptible seepage. Sometimes you may find that the water is just oozing out, trickling down, or maybe even 30 cubic meter per second, very high discharge may be there. So, it is a spatial arrangement of water and topographic slopes. So, topographic low spots provide the simplest mechanism for formation of springs. So, if your water table is being cut by the topography, then springs are formed. Now, if I give again the example of Himalayan conditions, since Roorkee is quite close, we have been visiting for various purposes, field and other. So, we keep seeing and observing all these things. So, that is why I am giving lot of examples from Himalayan conditions. That in Himalaya, you would find that sometimes it is just the slope is wet, but in monsoon time if you go, and there will be lot of discharge which might be coming from these springs. So, this wet slope are also indication that there is a recharge somewhere and that is water is being supplied. Now, temperature of water which is close to the mean annual temperature or lower or higher even boiling point, and we have also said that this will also follow and other things. Now, we come before we go for thermal springs and other things based on the temperature classifications, we would see the types of springs based on their locations, where they are located, and the 6 types of springs which we are seeing here. First one is the depression springs which are formed when the water table reaches the surface. An example here is that you are having some kind of lower areas and from where water is coming out and being formed, a drain is being formed from there itself. Now, this is because of change in topography creates a corresponding undulation in the water table configuration, and these kind of springs are quite common. A local flow system is thus created with a spring formed at the local discharge zone. The second other types may be there might be some geologic fault. So, faulting may create a geologic control favoring spring formations. Sometimes when we are looking in geological field works, when we are looking faults and if we find springs, that might be one of the manifestation of a fault on surface, because when fault cuts the rocks like here you are seeing, it is disturbing same time the groundwater table, and if groundwater surface is disturbed, then it might form springs as we are seeing here. So, faulting may also create geologic control favoring spring formations. A faulted rock unit that is impermeable may be emplaced again adjacent to an aquifer, and that may form springs. Now, you know that the Himalayan terrain is having a lot of seismic activities, and we have also observed that whenever we are having big earthquakes or medium earthquake like more than 6 magnitude or so, we have found that many springs locations have changed, they have shifted, and the reason is of course these faulting. Suppose a village which had a perennial spring, now there is no water. Because of faulting, because of seismic activity, the faulting has occurred and that has disturbed entire setup for the spring and no more spring. However, at some other locations, suddenly after the earthquake a spring may come up. So, these faulting and seismic activities also disturb lot of springs as well. Human interventions also play very important role, because like here like in this example third, which is because of rock contacts and other things, but if because of road widening and other things, if a slope is cut, then basically sometimes you may also cut a water table and springs will be created there also because of this cut which you are seeing here. So, faulted rock unit that is impermeable may be placed adjacent to an aquifer, which may cause the fault type springs, and this form a regional boundary to the groundwater movement and force water in the aquifer to discharge as a fault spring, which you are seeing in this example. Now, some other types of springs like contact springs, where relatively permeable rock units overlie rocks of much lower permeability, a contact spring may result like here. So, if there is lot of difference between permeability of different layers, especially in sedimentary rock setup, you may find a spring like this. Lithological contact is often marked by a line of springs, which may be either in the main water table or in a purged water table. So, that kind of contact springs are also seen in many parts of the Himalaya or in other hilly terrains also. So, one other important thing is that it is not necessary for underlying layer to be impermeable. There may be some other kinds of arrangement that a merely difference in the hydraulic conductivity be great enough to prelude transmission of all water that is moving through the upper horizon. So, that will also cause a contact spring. Now, one more type of spring, that is fourth type of spring, is the fracture spring or joint springs, which may be caused because of existence of jointed or permeable fault zones in a low permeability rocks. Again a very common thing, common arrangement or common setup in Himalayan conditions, where you may find because most of the rocks will have either fractures or joints, and they therefore you may find springs are generated or created because of this arrangement. So, in such thing the water movement through such rock is principally through fractures, and springs can form where these fractures intersect with the land surface at low elevation, and therefore, here you are getting the springs. In all these examples which you are seeing here, everywhere there is a change in topography or change in elevation, and there you are finding springs. So, so far we have discussed 4 types of springs. The same arrangement is there. That basically, as we have also discussed, that because of topographic arrangements or change, sudden change in the slope, and if that is cutting your groundwater table, then spring will be formed. Now, another type is about sinkholes, which is basically in limestone terrain, which bedrocks are limestone. Then springs, it is limestone terrain generally are having lot of springs even in Himalaya, and a very famous site in Himalaya is like Sahasradhara or Kempty Fall. These are all in limestone terrain. So, there might be some sinkholes or some very large springs, well known springs in Himalaya are located in limestone terrain. So, in such areas the runoff may be carried in parts of totally as subterranean flow, and the flow generally is very high in such. Recharge area may be very different. You need not to have a lot of changes in topography or elevation, but the 2 examples which I have given like Sahasradhara or your Kempty Fall, there is huge change in the elevations, and water basically vertically falls from top of few meters to the ground, and a quite good amount of water comes, and especially in monsoon season, and the Kempty Fall, like this is round the year you are having water. So, because of limestone terrain or the setup is completely different, and it may be either diffused flow in pores or a fractures in the rock or channelized flow in caverns. So, all kinds of as you can see in the water may be lot of water may be stored in limestone or similar kind of dolomites and other rocks. Now, springs finally can be found in a cavern, is connected to a shaft that rises to the surface. So, these we call them sinkhole springs, which are artesian pressure and comes from the principal artesian aquifer. Now, another type of spring which is a fracture zone, the last one, the such springs may be found along a fault or fracture zone, And this is the example which I wanted to give earlier about the Sahasradhara. This is the example which is coming from a fracture zone. You may have a arrangement something like this, not exactly this, but Kempty fall, this is though schematic. So, Kempty fall is something like this, which is shown here A, and the B is basically Sahasradhara, and these are all limestone terrain, but fractures or faulting are controlling factor, major controlling factor, and of course, they are recharge areas also. Now, as mentioned that I will now discuss two things, one is watershed and another one is a springshed and their differentiation. So, first let me define what is watershed. So, watershed is an area of land where precipitation collects and drain off into a common outlet. If I give the example here, the red line which you are seeing here is basically the watershed in this schematic, and this is the outlet. This is the outlet which from where the water is coming out. So, this is into a that may be converted into river, bay or other body of water. So, whatever the precipitation which is occurring within this boundary which is marked red, that will come out through one single outlet, and that is called the watershed. Identification of watershed in a topographic map or many times in satellite images is not a difficult task, but identification of a watershed or a springshed is really challenging. I will give you much more detail on that. So, this is an example that I have. There is a topo-sheet. On that topo-sheet you can easily mark watershed boundary. That means you are following the ridge from one end to and keep following the ridge and then you end up at the outlet. So, this becomes my outlet. Whatever the precipitation will occur over this area has to come out through single outlet. Another example here in the A, if I say A and B. So, in A what you are seeing contour lines. So, in a simple topographic maps like Survey of India topo-sheets, you can identify watersheds like this. First you have to decide the location of outlet and then you follow the ridge and you will end up again on the same point which is outlet. You may have some other thing in the background, like here we are having a hillshade or a shaded relief model, and of course drainage lines are marked here, and of course before that the watershed boundary are also marked. So, in this example the outlet is here. Now, very interesting thing, and that one watershed boundary ends, another starts, and basically theoretically there cannot be any gap on the surface of the earth. So, this watershed are continuous all over the land part of the earth. So, there will be some outlets, there will be some thing, but suppose if I decide that my outlet is here, then this watershed can become sub watershed and this will be like this also. So, a large basin will can have hundreds of watersheds and a watershed can have hundreds of sub watersheds. So, it depends where you are basically deciding the outlet. Anyway, this is the example very recently photograph taken by me and from the roadside, as you can see very easily that the watershed boundary even can be seen in the field like this, and this is again near the north of Kausani in Uttarakhand. Sometimes you from certain locations you can immediately mark the things. Now, this is a completely forested area, but if you see very carefully, inside there is a agricultural lands and villages are there. Though it is a small watershed, but the another aspect which I want to discuss here is that sometimes what happens if there is a cloud burst or intense rain with over this watershed, then there is a high chance of flooding, because all the water will come to the central part and whatever is there may wash out. So, a lot of problems because of shape of watershed might be there. So, that is also important. A circular watershed have got the more chance of flooding than a longitudinal or longer watershed. Anyway, that is a different. So, a similar kind of watershed, one more from the field you can very easily identify like this. that this is a watershed and the outlet is coming, a stream you can also observe. So, this is the outlet of that watershed. Whereas a springshed, what is a springshed? A springshed is an area of land that contributes groundwater to a spring, and whereas watershed, a topographic demarcation of high points or ridges where the water, whatever the precipitation occurs, which comes out in a single outlet. But here that springshed an area of land that contributes groundwater to a spring. So, springshed is definitely different than watershed. Watershed is mainly for the on the surface, whereas springshed is in creating a spring. The outlet of a springshed is a spring, and that is contribution to the groundwater. So, our actions within the springshed affect the quantity and quality of water flowing from the spring. Our actions means human interventions. Lot of human interventions or sometimes natural interventions are also there. Natural interventions, for example, maybe an earthquake event, maybe a landslide or a cloud burst and other things. So, these will affect the springshed, these will affect the quantity and quality of water which is coming out of a spring. So, these are very sensitive units, hydrological units, subsurface units, which are very easily affected by various factors. For example, here if I take this is ridge, then this is watershed 1, this is watershed 2, this is watershed 3 and this is watershed 4. And in all this thing, what you are seeing that these rocks are providing water and there is a formation of a spring here. Similarly, these rocks are providing water and there is a spring here. But important thing here that two watershed here are making one spring shed. Similarly, in this schematic, watershed 3 and 4 are making spring shed. So, what we understand now, with this kind of geologic arrangement that rocks are dipping on here towards if I say a section, then towards the east side, and they are creating 4 watersheds, but at the same time they are creating only 2 watershed spring shed. So, what we see here that a spring shed is larger entity than a watershed. So, if you want to understand that a spring should remain perennial, then that understanding is very much required. This is a very simple or schematic diagram which is there, but in natural conditions things may not be as simple as shown here, and therefore identification of a spring shed becomes very challenging. Now, there are 2 examples are here of different geological setup. This is the top one is the one which we have just discussed, that 4 watersheds are here and 2 spring sheds are here. Whereas, here in the bottom figure or B figure, what we are seeing same 4 watersheds, but spring shed is only 1, because the rocks are now dipping towards here towards east and here towards west, and therefore, they are creating a spring in between also. Here it was there also, but a geological setup in the part B or figure B is completely different, and therefore, the size of a spring shed is quite big, 4 times of watershed. So, this geologic rocks arrangements, their dipping, their structures plays very important role in case of spring sheds. May not play much role in watershed, because watersheds are based on the topographic ridges or topographic boundary, whereas spring shed is not depending on that. Spring shed is depending on the geological setup. This is the important point which play, and therefore, as mentioned here, that geology plays very important role in spring sheds. Now, here again I am trying to explain the same thing here, that here rocks are arranged like this, dipping towards east, infiltration is occurring, springs are formed, and there are permeable layers, there are impermeable layers are there. So, runoff is being created and then a stream is formed here, which you can see here, Another stream is also formed here, which you can see. Some evaporation may occur and other things. So, this is topographic watershed. These two are topographic watershed, whereas real watershed is having less size and the other one is having more size than topographic watershed. So, this kind of arrangements are also possible. So, what I am trying to say that the watershed are a smaller entity generally than a springshed. Further, identification of watershed is much easier using topo sheets or digital elevation models or hydrologic surface modeling. Other things can automatically identify watersheds. But identifying a springshed is really challenging, because it depends on subsurface geology, which you are sometimes you are not seeing any indication of that on the surface of the earth. So, watershed, as just to recap the thing, that watershed is a topographic boundary where surface hydrology plays important role, whereas a springshed is a completely different thing, which is having geological controls and groundwater has significant influences. So, two are different, completely different things, but they are very important from a spring point of view. So, no two watersheds or springsheds are identical. This is another very important thing. You go in any hilly terrain, if I give again example of Himalaya, each watershed is unique by itself, each springshed is unique by itself, because the geology is different, topography is different, and therefore, springs will also have different discharges and other things. So, if we like a lot of one organization I know, that is G.V. Pant National Institute of Himalayan Environment, located in Almora, they are doing extensive work in Indian Himalaya, where they are monitoring, mapping and monitoring all watersheds. But in their work, they do not have much information about springsheds, because identification of a springshed is a real big challenge, because then you are talking about subsurface geological controls or setup. So, springshed recharge possibilities. If we want that our springs should remain perennial, they should provide constant discharge throughout the year, then this is the possibility that we should identify first the springshed, delineate the springshed, and then take the necessary steps like in some kind of watershed management, so that we can have clear identification of a springshed, and consequence of that we will have a constant discharge springs. So, delineation of springshed, as I have multiple times said, really challenging. Usage of environmental isotopes is one of the modern technology. This is what it is being used many times to find out the springsheds, from where the water is coming in a spring, and for which some isotopes which are friendly to environment are used, and then springshed boundaries. But again, this is not also very perfect technique, but one of the techniques available by which one can try to identify or demarcate a springshed, at least the recharge area from where the water is getting recharged. And if we can identify the recharge area for a spring, then the treatment and sustainability issue will come very easily, or can be solved very easily. So, best solution towards the springshed development is the recharge groundwater regime across watersheds. This is a kind of blanket solution, that if you manage all watersheds which are topographic, having topographic control, if you manage all watersheds, then our springs will have more water all the time, constant water all the time in this area. So, there are various schemes which are going on, various lot of research is going on when restoration of springshed, that the springs which we are known to supply a very good amount of water, quantity of water, even quality of water, how can we restore, how can increase the recharge there or discharge from such springs. So, goal of springshed restoration are same to those of watershed management. Same techniques as said earlier, that if we do good watershed management, then our springs or springshed will also manage, we will reduce the soil erosion, we will increase the vegetation cover, soil organic matter, and that is all helpful from environmental point of view also. And we will increase the natural infiltration of water into soil and recharge of aquifer. Further, protect the area to allow ecological restoration. That means the entire area should be protected and prevent pollution of groundwater and surface runoff by maintaining cleanness in the catchment area. So, good watershed practices throughout all watersheds can restore our springs or springshed very easily. So, that ultimately what we will do, we will augment the natural infiltration and recharge through best practices. Now, we are reaching at the end of our discussion on springs. Two more discussions we will have on springs like thermal and others. So, before that, the estimates suggest that a mountainous terrain less than 15% rainfall percolates down to the recharge springs, while the rest is lost as surface water. And this is what is a serious thing, this quantity, this percentage. By some means, if we can reduce this or increase this towards the groundwater and reduce the surface runoff, we will have better spring conditions, better discharge from springs, and that can only be done through best practices which are known, tested, demonstrated about the watershed management. So, if we do better watershed management, springshed will automatically manage, because if two watersheds, in earlier discussion in schematic what we have been seeing, two watersheds are making one springshed or four watersheds are making one springshed. So, if we maintain all four watersheds, manage four watersheds, then our springshed will be there. So, there are some human interventions can be done, and like similar which are in the watershed management, like reservoir, like trenching which you are seeing here. So, that we are basically intercepting the flow of water by these interventions, and by which there are many other methods of improvement of watershed or management of watershed, but just two examples I am giving here, because our discussion is on springs, not the watershed management. So, with this I thank you all. Thank you very much.